Hello, my name is Mitchell Sheep, and I'll be presenting contributions to mathematics in the African Diaspora. The phenomenon of the African Diaspora is the history of the dispersion of the people living in African continent around the world, specifically to the northern and central America by the events such as the triangular trade from Africa to America and England, where agricultural exports will be brought to England, which would transport manufactured goods to Africa, then bring slaves to the farm the agricultural products in America. Beginning as early as the 15th century by the Portuguese and Spanish traders looking for labor to farm sugar cane and other products in the Caribbean, they turned to the continent of Africa, which had little to no exports, but the Spanish and Portuguese sourced the local population as slave labor for their plantations. With the trade route being established after the British signed the Treaty of Utrecht in 1713, it lasted up until the American Revolutionary War in 1776. This leads to the focus on America as the biggest concentration of the diaspora, where slaves transported to the colonies of European countries became part of the culture. This not only meant the gleaning of language and behaviors, but the adoption of religion and science, which was helped by with the countries like the newly founded United States being of both deeply religious and very concentrated on science. The U.S. having a rapidly expanding number of universities as well as other institutions, it would become a tree with fruit ripe for the picking. However, due to slavery, most Africans in the Americas and abroad were seen as property with no right to liberty freedoms granted by the U.S. Constitution. This was not to last, however, as people like the third President of the United States, Thomas Jefferson, was quoted as comparing them by their faculties of memory, reason, and imagination. It appears to me that in memory, the African American are equal to the whites. In reasons much inferior, as I think one could scarcely be found capable of tracing and comprehending the investigation of Euclid, and that in imagination they are dull, tasteless, and nameless. Though he himself owned slaves, a renaissance would slowly shine a light on the dormant abilities of African Americans in STEM. Mathematics has One such example is the African born slave Thomas Fuller, who was taken at age 24 in 1724 from his home in Africa. Though, like most slaves, he could not read or write in English, he was deemed the Virginia calculator due to his ability to compute 10-digit plus outcomes in his head. Most famously, he was quizzed on how many seconds is a year and a half and how many seconds is in 70 years, 17 days, 12 hours, to which he gave the correct reply of 47,304, 47,304,000 seconds, and 2,210,500,800 seconds. Even during slavery, African Americans showed extreme talent, such as Benjamin Banneker, who self-educated in astronomy and trigonometry, being able to construct a device that ticked hourly in predicting the 1789 solar eclipse. He became a symbol for abolitionists and a role model for many aspiring African mathematicians to come. Even in the events of these two, sentiment continued past the abolishment of slavery in 1865. Academia itself did nothing to help, becoming a deterring factor with the fields of psychologists, where professors of Stanford stated that Negroes and Mexicans could not master abstractions but rather made good workers, though this would not stop others from making their contributions to mathematics, as a man by the name of Dudley Weldon Woodard would become one of the first tutors for the aspiring mathematicians in the African American community. Woodard, born in 1881 in Galveston, Texas, would earn a B.S. degree from Wilberforce University, a B.S. and M.S. degree from the University of Chicago. He went on to teach collegiate mathematics at Tuskegee, Pennsylvania, where in 1928 he earned a Ph.D. for a dissertation entitled One Two-Dimensional Analysis Situs with Special Reference to the Jordan Curve Theorem, being advised by Dr. John R. Klein. He would go on to publish 3 articles in his lifetime, the second of which, the characterization of the Claude's incel in Fundamenta Mathematica in 1929, was considered to be the first paper published in an accredited mathematics journal by an African American. He would even publish a textbook, Practical Arithmetic, in 1911, and an article in geometry about teaching at Tuskegee. Dr. Woodard was a respected mathematician, professor, and mentor to his students teaching at Howard University, where he founded the Graduate in Mathematics program. One of his best students William Walden Shefflin Claytor would also obtain his PhD in 1933. Under the same mentor, John Klein, Woodard's mentor, Albert Frank Cox, was was the first African American to receive a PhD in mathematics from Cornell University for his dissertation, "The Polynomial Solutions of the Difference Equations of a function a times a function x plus 1 plus b times a function x equals theta x." Cox had previously received his bachelor's in 1917, or later enlisting on the U.S. military to fight in France in World War I. He returned and became an instructor/tutor for mathematics for high school in Henderson, Kentucky, where he applied to Cornell University. He would teach at all-black Western Virginia State College, where thanks to his PhD and connections made during the war, he received a hefty salary and made subsequent changes to the curriculum from 1925 to 1928. He would later teach at Howard University, where his mentor tried to get his graduation papers published and recognized. With it being rejected by English and German universities, he finally gained recognition from Tohoku University in Sendai, Japan, publishing it in the Tohoku Mathematical Journal. Though he was pursuant in his research, he was an active teacher, directing more master's students than any other professor at the time. He would see his own son, Albert Lucian, and his student, and the third African American to receive his PhD, William Shefflin Claytor. Cox published 2 articles expanding on the works of Niels Norland, doing Euler polynomials as a solution to a particular difference equation. These equations are recursively defined as a sequence of multidimensional array of values once one or more of the initial terms is stated. Every further term in the sequence or array is defined as a function of the preceding term. He would also use a generalized Euler formula and Boole summation formula to expand on the Boole summation. He studied a number of specialized polynomials as outcomes for certain differential equations. With African Americans having received PhDs in the field of mathematics, the first African American woman, Euphemia Lofton Hayes, would receive her PhD in 1943. Hayes was raised in Washington, D.C., making her name in the academic realm, getting degrees in both math and education, becoming a sweeping change for the face of education, for which African American students were falling into a predetermined segregation. Also being devotedly Catholic, she would devote her life to that as well. After she received her master's degree from the University of Chicago in 1930, she founded the mathematics at Miners Teachers College, renamed the University of the District of Columbia. As a professor at the college, she became head of the math department for over 30 years. She received a PhD from the Catholic University of America. From there, she would become an educator at several high schools in the D.C. area, also becoming the chair of the Division of Mathematics and Business Education, being an advocate for poor students and better schools, fighting against the segregation-based policies in the education system. She rallied herself around many causes she has a strong inclination towards her Catholic religion, supporting the poor and advocating for the education of the American community, leaving her legacy as the first African American woman in a PhD and her overwhelming passion and drive for the education system to be better and for the betterment of the student. Though many achievements are not glamorous in the long run, they nevertheless leave their mark upon the world, being good or bad. None such project encompasses a sentiment in the Manhattan Project for the United States research and development into building the atomic bomb. One such advocate of this bomb was J. Ernest Wilkins Jr., who did work in metallurgy, such as finding fissile materials like uranium-235, which is 3 less neutrons than uranium-238, the natural occurring form of the element. J. Ernest Wilkins, born in Chicago, Illinois in 1923. Wilkins, just 13 years old, was accepted at the University of Chicago in 1936, obtaining a B.S. in math in 1940 and gaining notoriety in the media as a Negro genius. He would later receive a bachelor's and master's in mechanical engineering in 1982 and 2001, respectively, years after he had already made considerable contributions to science. Though he would fail to secure research at his own alma mater, he taught mathematics from 1943 to 1944 at the Tuskegee Institute, known today as the Tuskegee University. He would return in late summer of 1944 to become the first associate mathematical physicist and the and as a physicist of metallurgy lab, and the leader at the physicist metallurgical laboratory as part of the Manhattan Project. Working while directed by Enrico Fermi, the father of the bomb, himself, he performed research in the extraction of fissile nuclear materials. Unbeknownst to him that it was for creating a bomb, he continued his work diligently and became the discoverer and co-discoverer of Wilkins effect and the Winger-Wilkins spectra. After the war, he would design the nuclear reactors for generating electrical power and became a part owner in a company that specialized in such design. Wilkins even served as the president of the Nuclear Society from 1974 to 1975. In 1976, became the second African American to be inaugurated into the National Academy of Engineering. Until his death at 87, Wilkins published over 100 papers from differential geometry, linear differential equations, integrals, and nuclear engineering. Another influential African American mathematician was Katherine Johnson, who was involved in the United States space program at the National Aeronautics and Space Administration, NASA. She would join the nationwide effort to put a man on the moon in response to an ongoing space race with the Soviet Union that began in 1957 with the launch of the first satellite, Sputnik, which is the buildup of achievements that led to President John F. Kennedy's famous declaration: the U.S. would land a man and bring him back from the moon before the end of the 60s. Born in White Sulphur Spring, West Virginia, in 1918, Catherine was the youngest of 4 children, showing an affinity towards math at an early age. She would be forced to attend High School Institute of West Virginia, since Africans could not attend school past 8th grade in her hometown. Graduating high school at the age of 14, she was enrolled in West Virginia State College, where her high school was located on the WVSC campus. She would take every mathematics class available at the college and was mentored by W. Shefflin Claytor, who added a new mathematics course just for Johnson. Johnson would graduate summa cum laude in 1937 with a degree in mathematics and French at the age of 18, after which she attended graduate school at West Virginia University in Morgantown, becoming one of the school's only 3 African students to attend the graduate program. She would get a job recommendation for the National Advisory Committee for Aeronautics, or NACA, which were hiring mathematicians. Working in the Guidance Navigation Department from 1953 to 1958 as a computer, where she analyzed topics of gust elevation for aircraft. After her tenure at NACA, she would be moved to NASA as the departments changed hands, as an aerospace technology in the spacecraft control branch. One of her earliest accomplishments was calculating the trajectory for the May 5th, 1961 spaceflight of astronaut Alan Shepard, becoming the first American in space. She would even verify the computer calculations for John Glenn's orbit around the Earth, where he specifically asked for her, refusing to launch if she was not doing the checks. These calculations were far more difficult calculations, having to account for gravitational pulls of celestial bodies. Her calculations were so accurate, NASA used her work to verify calculations of IBM's computers, inspiring confidence in the new technology. Most notably, she worked out the trajectory of the 1969 Apollo 11 moon landing flight. Later, she would contribute to the rescue of Apollo 13 capsule, with her calculations being used as an alternate path to get home, as well as using a 1-star method for determining location and accuracy. She would contribute to the Space Shuttle program, Earth Resource Satellite, and the plans for a mission to Mars. Still waiting on that one. One of the more modern examples of contributions in forward progress in mathematics is John Urschel, the Canadian-American who was accepted to Pennsylvania State University as part of the football team. While at Penn State, he would be involved with teaching integral vector calculus, trigonometry, algebra, and machine learning. He would be drafted into the NFL in 2014, but wanted to continue his education at the Michigan Institute for Technology, or MIT. But they do not allow students to attend part-time, so between his NFL career and school, he balanced them brilliantly and was awarded the Forbes 30 Under 30, proving that you can do sports and academics at the same time. And that is my paper. Thank you.